Good morning, guys. This morning I found a very cool GitHub project which can reveal how different machine learning models work behind. That means you can to check how different machine learning models performs a training progress or can work from mathematical side. And then you can leverage some parameters like learning rate or epochs or some epsilon and check how the different machine learning models change its performing, and you can check it on very good prepared visualizations. And this is the GitHub repo that I want to clone on my local computer. Just git and clone and paste this link, and yeah, just wait a little bit and we have the clone repo on my laptop. So just a couple of seconds and it will be downloaded. And what I can to say more about this project, that this is growing, and for now we have KMeans, Gradient Descent, linear regression, and Logistic regression. But I see the potential of this project and I suggest you to follow it up. So I have the local copy on my laptop, so it's a good idea to create a virtual environment, especially for this small project. Let's name it machine learning models graph, and yeah, it's being created. And let's activate it and start using this repo. Yep, source and machine learning graph been activated. Okay, I have activated my virtual environment, and right now I'm having my repo and my virtual environment folder. So let's go to the repo project, and in here I have the many files, not many files, but the very clear structure and requirements files that I want to install dependencies from. So let's install all dependencies from requirements file is from here, and starting to do it. It's collecting NumPy and scikit-learn, Seaborn, Matplotlib. It is, as I remember, 4 or 5 different libraries with dependencies that we will need for this project. Yeah, we can open this requirement file, and yeah, it's just a 4 libraries: Seaborn, Matplotlib, NumPy, and scikit-learn. Nothing more. And with this we can check dependencies, and it's not too much. So so everything fine so far, and we can to start using this repo in practice. So here's the main files that are available to run, and it is like Gradient Descent, KMeans, KNN, linear regression, logistic regression, and some of these can run on 2D or 3D dimensional space. So let's open the folder in our computer, and you can see the same structures in here. Yeah, that's looking good. And now we can to start to run the file to see how it's working. Let's start from Gradient Descent in 3D space, and just paste the name here and 3d.py, and just run it. We see some information about how it's performing. Okay, and now we can see a very nice graph interpretation of the model, and you can see the learning rate is growing, is changing the direction, and it's very cool representation of the model performing. And when you close the window, you can see some summary distributions on x and y axis. I'm not going very deeply into this in this video. You can save it in your local computer as PNG file, but I want to highlight the performance itself of this project. So secondly, we can run a second file. Let's say it can be okay, KMeans in 3D space. So run KMeans and 3D. Yeah, that's like this, and run it. Okay, and as you can see, we are now in KMeans space, and that means we have drag and play with the mouse and see the distribution of our clusters. Okay, but for example, what if I want to change some parameters? For example, I want to change number of clusters not to be 4, but I want to change it to be 3. And you can see from the source code, you can change more parameters, not a number of clusters, but it depends on the model. And I want to change the number of clusters, and when enter to the terminal, I just need to add a n classes parameter. It's like this will be a 3. Okay, and run it again. Okay, we can see a 3D space with only 3 clusters on KMean model. Okay, this is a very simple way how you can to change arguments for each available model in this project, and run again. Okay, gradient descent on the 3D space. Yeah, 3D space.py, and it is a learning rate is 0.03. It is the same visualization as we have seen before. So I want to change learning rate for this model. How I can do it? Where is a learning rate argument in this list? I'm just looking, and yeah, it's the first one is LR. So in the terminal, I need to add minus minus LR, that stands for learning rate, and change it. Let's say it will be 0.02. Yeah, remember before we had a 0.003. So now we have a little bit different shape of training curve, and you can compare different scenarios for the same model. That is very cool in learning, machine learning, and it's very cool stuff when you need to get a better feeling of different machine learning performance. So let's do the same with gradient descent in 2D space. And I think you got an idea how you can to manipulate with the models, and how you can to leverage the functionality to change arguments for the models. And right now you can see gradient descent on 2D space is the learning progress is trying to find a global minimum. But let's change the argument of learning rate, not 0.03, but let it be learning rate 0.01, and you can see how it will be changed. You see, this training progress is getting a little bit slower, but it finds a global minimum as well. So you can see differences, and at the end, when you close the main window, you can see distribution of gradients. So you can to analyze it by yourself in your free time, in your learning progress. So, and at the end, you can see some information on the terminal. So again, come back with the main repo. I see a big potential for this project, and I will follow up with the growing of this. And that's what I wanted to share with you, and I suggest you to play yourself in this project. So that's it for today. If you want to get more similar contents, please subscribe me in this channel, and see you on the next video. Bye bye.